Good afternoon to everyone, and thank you for joining today's webinar. From my side, my colleague Tomislav presented me, but I will explain that my name is Sabina Hadžiahmetović. I'm coming from Hydroengineering Institute in Sarajevo, and I'm working as water engineer, designing water supply and wastewater systems. And I want to say at the beginning, and something repeat what my colleague before emphasized, that our countries in Western Balkan have many problems with wastewater treatment plants because we have now started with a new wastewater treatment plants, and I think that this presentation and our consultation in this manner is very important to speak today, because we are now in the beginning of the designing our new wastewater treatment plants. Practically, we have many projects, especially in Bosnia and Herzegovina, to start with a preliminary project related wastewater treatment plant. And in this phase, we have to think at this moment about these problems. So today I will be discussing innovative water treatment technologies for microplastic removal. Over the next 20 minutes, we will explore the growing challenge of microplastic pollution in water systems, review both conventional and innovative treatment technology, and discuss future trends and implementation challenges. Microplastics have become one of the most important emerging environmental issues, and addressing them will require both technological innovation and preventive action. Tomislav, you can go with slides, please. Here you can see some data about release of microplastic in the water. But please, for next slide. Microplastic, generally, I want to remind you at the beginning that microplastic are plastic particles smaller than 5 millimeters that originate either than internationally manufactured small practices or through the breakdown of larger plastic products. Today, microplastics have been detected almost everywhere, in rivers, in lakes, groundwater, wastewater, drinking water we have also, and marine environments. Why is this issue receiving so much attention? First, plastics are highly persistent and can remain in the environment for decades. Second, microplastics are now widespread through natural ecosystems. And third, and very important, there is increasing concern about potential impact on aquatic organisms, biodiversity, and human health. With the global plastic production exceeding 400 million tons annually, preventing plastic pollution has become a critical environmental priority. So please, next slide, Tomislav. Microplastic enter water system through variety of sources. Domestic sources include synthetic textiles, as my colleagues explained before me, household products, and personal care products also. Urban sources also include tire wear, particles, road runoff, and stone wall drainage systems. Industrial activities such as plastic manufacturing and industrial wastewater discharges also contribute significantly. Once released, microplastics typically travel through sewer systems to wastewater treatment plants. Although treatment plants remove a large proportion of these particles, some still reach rivers, lakes, and eventually marine environments. One important fact is that washing synthetic clothing is considered one of the largest sources of microplastic fibers entering wastewater systems. Also, my colleague in detail explained about this problem. So next slide, please, Mir. Microplastic interact with ecosystems in several ways. Aquatic organisms can ingest them directly, allowing microplastic to move through the food chain and potentially affect biodiversity. In addition, microplastic can act as carriers for toxic chemicals and microorganisms. A recent study have dedicated microplastic in drinking water. Especially, I have to explain that some public utility from Bosnia and Herzegovina was included in some study in some research last 3 years in Dunav region project for Western Balkans, and we found in monitoring microplastic in our drinking water. Also, a recent study have dedicated microplastic in seafood, human blood, placental tissue, and even human lungs. Although research on long-term health effects is still ongoing, and these findings highlight the importance of reducing microplastic pollution before it enters into the environment. I will say something about conventional wastewater treatment performance because I don't know about our participant. Maybe we have water expert, maybe we have textile industry expert, NGO experts, etc. But I will very shortly explain about a conventional wastewater treatment performance. Wastewater treatment plants already play a crucial role in reducing microplastic emissions. Primary treatment at wastewater treatment plants removes larger particles through screening and sedimentation. Secondary treatment further reduces concentration through biological processes and clarification, and tertiary treatment can achieve removal efficiency about 95%. However, very small microplastic particles and nanoplastics remain difficult to capture, which is why additional treatment technology and increasingly being considered. So next slide, please. Membrane filtration technology. This technology are currently among the most effective methods for removing microplastic from water and wastewater. Depending on membrane pore size, different processes can be used, including microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. As pore size decreases, removal efficiency generally increases. Reverse osmosis provides the highest treatment performance and can achieve a near complete removal or suspended particle and many contaminants. However, these benefits come with challenges, including membrane fouling, high energy consumption, and increased operation cost. Despite these limitations, membrane technology are widely considered the benchmark for advanced microplastic removal. So next slide, please. I will say something about membrane bioreactors. Membrane bioreactors combine biotechnology wastewater treatment with membrane filtration in a single integrated system. Organic pollutants are biologically degraded while membranes retain suspended solids and microplastic particles. Studies have reported from another country have reported removal efficiency ranging from 95% to nearly 100%. Another important advantage is that MBR systems produce very high quality effluent sustainable for water reuse application. As membrane technology continue to improve, MBR are becoming increasingly attractive for future wastewater treatment facilities. And please, next slide. On the next slide, we will explain about electrocoagulation technology. It is an innovative treatment process that uses electric current and sacrificial metal electrodes. The released metal ions from hydroxyl flux that capture microplastic particles through adsorption and aggregation. These flux can then be removed through sedimentation or flotation. One major advantage of electrocoagulation practically is that it can simultaneously remove microplastic, heavy metals, and suspending solids and certain organic pollutants. Because on its relatively simple operation and limited chemical requirements, it represents a promising solution for both municipality and industrial wastewater treatment. And also, next slide, please. We will explain about another solution for wastewater treatment plant. It is advanced oxidation processes, often called AOPs, offer a different approach. Instead of simply separated microplastic from water, these processes can chemically alter and partially degrade plastic polymers. Example include ozonation, ultraviolet hydrogen peroxide treatment, oxidation, and photocatalytic oxidation. And one additional benefit of this technology is to remove pharmaceutical pesticides and other emergent contaminants. The key challenges of this solution is optimizing operation condition, since treatment efficiency depends on factors such as oxygen dosage, contact time, and energy input is also very important for this solution for wastewater treatment plants. And also, please, for next slide. We will say something about photocatalytic treatment. Is considered one of the most promising future technology for microplastic degradation. It uses semiconductor materials such as titanium dioxide or zinc oxide that become activated when exposed to visible light or ultraviolet. These materials generate reactive oxygen species capable of breakdown plastic polymers. One particularly attractive feature is the potential use of solar energy, which could reduce operational cost and environmental impact. Although most applications remain at laboratory at pilot scale, and photocatalysis has significant long-term potential. And also, at the end, we will explain about nature-based solution. It is next, sorry, Tomislav, for A, yes, nature-based solution. Nature-based solution is today very popular, and this is a solution offer a suitable and low-energy approach to improving water quality. Examples include constructed wetland, biochar, vegetated swales, and floating treatment wetlands. Microplastic removal occurs through natural processes such as sedimentation, filtration, absorption, and biological interactions. While removal efficiency are generally lower than those achieved by advanced engineered systems, these approaches provide additional environmental benefits, including biodiversity enhancements, carbon sequestration, and climate resilience. For this reason, nature-based solutions are increasingly promoted as complementary measures within integrated water management strategy. And maybe we can go on the next slide. I will say something about future trend and integrated solutions. Looking ahead, the future of microplastic removal will likely rely on integrated treatment systems rather than any single technology. Emerging solutions include magnetic separation, nanofiber membranes, and artificial intelligence-based monitoring systems. Artificial intelligence can help optimize treatment performance, improve monitoring, and support predictive maintenance. The future wastewater treatments are expected to. I think that we can conclude with this that future wastewater treatment plants are expected to combine membrane technology, advanced oxygen processes, electrocoagulation, nature-based solution into hybrid systems that maximize efficiency while minimizing cost and environmental impacts. Maybe I prepare for you some European case studies and best practices at the end of this presentation. Tomislav, we can go on the next slide. Several European countries are already implementing innovative approaches to microplastic removal. For example, the Netherlands is recognized for advanced membrane filtration technology and water reuse schemes, demonstrating removal efficiency about 95%. Also, in Germany has introduced a fourth treatment stage in many wastewater treatment plants, often including ozonation and advanced filtration technology. Regarding Sweden, Sweden has invested heavily in membrane bioreactor and resource recovery integrated microplastic removal into broader sustainable objectives. Regarding practice from Denmark, Denmark has become a leader in smart water technology, combining advanced treatment systems with digital monitoring, sensor, and artificial intelligence. Although the technology differ, these examples share an important lesson. The most successful approaches combine multiple treatment technology and emphasize both prevention and treatment. And regarding my presentation, we can at the end to conclude we can conclude and to highlight several key messages. First, no single technology can completely solve the microplastic challenge. And second, the most successful European example combine multiple complementary treatment technology. Third, membrane filtration and membrane bioreactor currently provide the highest removal efficiency. Fourth, advanced oxidation processes offer the additional advantage of degrading pollutant rather than simply separation them. Finally, digital monitoring, artificial intelligence, and preventive measures will play an increasingly important role in the future water management strategy. In our country, in Western Balkan countries, we are now in the preparing new water strategy. In Bosnia and Herzegovina, we received last year new water management strategy, and we will go in this way related to planning our new wastewater treatment plant. Maybe I don't know how are with the time, Tomislav. I think that I'm in the time. 20 minutes for my presentation.
Yes, it's now about 20 minutes.
10 after 3. So it is what I prepared about clearly about that we think about now about planning and about starting with new wastewater treatment plant, because in Albania, Bosnia and Herzegovina, North Macedonia, Montenegro. I was last month in May in Montenegro with our colleague from Zero Waste Montenegro. They are practically at the beginning way on the constructing of a new wastewater treatment plant. And what is important to say also that we have a wastewater treatment directive, European Union wastewater treatment directive, which are completely integrated in our water legislation in our countries, and is something we have something new in this wastewater treatment directive. It is second phase of treatment at wastewater treatment plants. So it is excellent time to speak on this problem in our project and in our webinar today. We are very actually